Pressure and water depth. What is the relationship between them? Let's consider this water column of area A and depth h. Its volume is AH, and if its density is ρ, then its mass is ρAh. If there is gravity, then its specific weight will be given by gamma equals to ρh. The weight will be mg, so the weight of the water column will be ρgAh, or gamma AH, which is the same. If the water column has its weight, there will be a vertical force F sustaining it. Its intensity is equal to the intensity of the water column weight. We can write it using ρ or gamma as you wish. Let's bring these expressions to the top of the page. As we know, P is equal to F divided by the area. So, we obtain these expressions for the pressure. Our problem is solved. We only must know the values of ρ and gamma. As we know, water is incompressible. Is it? For most of our purposes, we can assume that it is, but we must talk about this later. Okay, we are assuming that ρ is constant. Now, about the G value. It varies from about 9.78 meters per squared second at the equator to approximately 9.83 meters per squared second at the poles. So, we'll assume that G is constant, and it's equal to 9.8 meters per squared second. It's good enough for our calculations. Let's run an example. What is the pressure at the bottom of this recipient? First, let's use this expression. We just put on the values and find the pressure that we want expressed in pascals. Now, let's use the expression that uses gamma. We must find its value. As we know ρ and G, gamma can be easily found. Now we calculate P by substituting the values of gamma and H, and of course, we find the same value for the pressure that we have found before. When G equals to 9.8 meters per square second, we find the pressure of 980,000 pascals. But in many practical cases, we assume that G equals to 10 meters per square second. In such cases, we find P equals to 1 million pascals, or 1 megapascal. So we can write that when the pressure head equals to 100 meters, the pressure equals to 1 megapascal. Let's write what we saw in a different way. Look at this water column. There is a point A situated ZA meters above the horizontal plane that we are calling datum. Also, there's a point B situated ZB meters above the datum. The difference between ZA and ZB is what we are calling H. So, PB minus PA equals to gamma H. We can write it as PB minus PA equals to gamma ZA minus ZB, or ZA plus PA over gamma equals to ZB plus PB over gamma. This looks a lot like an expression that we've seen before, doesn't it? Oh yes, in a previous video. I'll leave a link in the description below. The difference is that VA is 0 and VB 2. Here are the elevation heads and the pressure heads. It means that all points inside the vessel have the same head, or the same energy as we saw. The more elevation head, the less pressure head, and vice versa. But the sum of the heads is the same for every point. The same will apply to two vessels connected between them. If the points A and B are at the same depth, they will have the same pressure. Even in this dam, A and B have the same pressure. But wait, there is still something strange about what we saw. We are assuming that the pressure above the water level is 0. I'm sure it isn't. And you're right, we'll talk about this in another video. I think that's enough for today. Oh, and if you liked this video, don't forget to give it a like, share, comment, and subscribe. Hit the bell so you can be notified of my next videos.